This talk is Gradle is DevOps glue. It's how we glued an on-premise product into a simulated DevOps pipeline. I'm Adam Roberts. I'm a tech lead on the cloud infrastructure team at Pros Incorporated. And that's pretty much the only thing you're going to hear me talk about cloud for the entire day, because this is about the stuff we did before we started transitioning all our products to cloud. But to understand the background, I got to go a little over history. So Pros was started in 1985. And for those of you who have only ever worked on web applications, to just be aware, depending on who you talk to, the internet founded between 86 and 91. So we predate the internet. Cloud computing was kicked off by Amazon Web Services around 2006, and DevOps was coined in 2008. So it's pretty obvious that we have a large backlog of products that don't support cloud or DevOps or whatever. But we do have a long history of evolving with technology. We've gone through multiple languages over time. We have upgraded everything, so we don't want to let ourselves fall behind when it comes to DevOps and cloud deployments, but at the same time, our products, especially our on-prem products, really don't fit it out of the box. So we currently have around 20 products and around 20 on-prem products and about 8 software as a service products, and 4 of those were DevOps from day one. This talk is only about the on-premise products and how we were able to get a lot of the benefits of a DevOps pipeline and automation throughout the build cycle, or the development to deployment cycle, for an on-premise product where we don't control the final production deployment. So the challenge of automation was, honestly, we kind of started this because we kept being told we couldn't do it. And we didn't like being told we couldn't do it. So we wanted to get rid of all of the manual effort and prove the naysayers wrong. So our automation started with deployment automation. And deployment automation in the DevOps world where you control the servers is pretty simple. Your development automation and your test automation and everything should be as similar to the way your operations team does the production deployment. But when we don't control the production deployment, and in fact we've got dozens and dozens of customers that all deploy in completely different ways, how do we do our deployment to get all of the benefits and reproducibility and bug catching that a normal DevOps in-house deployment gets without controlling it? And it basically boils down to, instead of mimicking operations, you have to mimic the customer. It seems really, really simple, but a lot of people resist it because it's more work. So to mimic the customer, you have to know what the customer does. And it starts with, they run our installer. It's a standard third-party commercial install package. I guarantee everyone here has run it at least once for some product sometime. Then they configure the product, and then they load data, because a product without data in it's pretty useless. Now in reality, the configure and the load is kind of a back and forth cycle for them. But this is the general workflow of a customer deployment. So our first step, of course, has to be automate the installer. And when we were doing the automation of the installer, we had a couple false starts. Our first attempt used the silent install mode that came with the installer. The problem with that was it's not the way our customers deploy it, and maintaining that automation was very technical, and you needed to have inside knowledge of how the installer worked to keep it working as the product evolved. So this stumped us for a little while. I mean, we had success. We were at least getting faster deployments, but it wasn't really perfect. So what we figured out was we could automate the installer console mode. And console mode is literally in the installer, so that if you're installing on a headless Linux server with no UI, it just asks you a question and you type in a response and hit enter. And this becomes really, really easy to automate by just running the installer inside a JVM with Process Builder, and you grab the input and output streams. You read from one, you write to the other. So we ended up wrapping this in a Gradle task. Here's an example of what the Gradle task looks like when you're using it. You define the task, you tell it where to find the installer tarball, and the first thing it does is unpack the tarball, and then we have a list of console values. A map of console values. And what the plugin does is it's reading the text from the installer, and every couple steps it checks, does the text from the installer end with a key in the map? And the moment that's true, it writes the value from the map to the installer. So it's not really a map of key value pairs, it's a map of questions and answers. And this is nice, one, because it exactly mimics the way the installer is run by our customers, at least from a logical point of view. They generally use the UI, but same thing. But it's also incredibly easy for our business users and our quality engineers. Oh, wait, sorry, wrong slide. So here's what the DSL in use looks like. You create a task. Our DSL requires you to set a project variable that contains the path to the installed application. And then in the do first, you do the DSL. So we tell our business users when they're maintaining this, ignore all the Gradle task stuff. Just look inside this do first block, and the language there makes sense to you. So they can maintain this for us. So in this example, the first step is starting services, and then we add a value to a user property file, and then we invoke product tasks. Our DSL ends up being about 50 sentences long. Didn't take long to write initially. And the business users at this point, an average task will have between 50 and 200 steps to configure and load the data, and we have dozens of them. And because we did it in a DSL, the developers only had to write the first one to show them how to do it. The implementation is absolutely easy, and I guarantee at least someone in here is going to go, that's not the Gradle way, there's a better way. We just did groovy metaprogramming directly on the Gradle project object. We're adding the DSL methods to the Gradle project object when you apply the plugin. I know there are better ways. I know I even know how to do some of the better ways. But here's the thing, we got 90% of the DSL written in 4 hours, one day in our free time. So we've never actually run into a problem doing it this way, although I suspect once we move into some of the newer versions of Gradle with 3.0 and them talking about hiding some API stuff, we might run into problems. Our DSL commands, the internal implementation like this one, it's frequently just doing an exec or a Java exec. In some cases, we had to do a bunch of code because we want to be able to call web services in certain cases, but even then, it's still pretty simple. So why did we do Gradle? Obviously, I didn't just write the plugins in Gradle so I could give a talk here. Why didn't we use Rundeck or Chef or Puppet or any of the other tools that were designed to do this kind of deployment automation? And it literally boiled down to, it was quicker in Gradle. It was just amazingly fast to get it up and running in Gradle. And dependency resolution is part of that. We don't have to deal with downloading files or uploading or writing stuff to unpack a zip. We can literally use dependency resolution for all of our file retrievals. So in this case, earlier I showed you the silent install mode that we have, and it just had path to tarball was 3 dots. In reality, we're using a configuration, just a standard Gradle configuration, .single file, and it downloads it for us into a location we can use. Same thing with all the data files. We used to have the data files checked into version control, and when someone was loading up the data, they just cloned version control. All we did was drop a Gradle project into that repo that publishes all those data files into a zip, and now we can resolve them at any time. No, we actually treat our data load files as part of the product. They are released with the product. So one thing with on-prem deployments, you have to do upgrade testing from many different versions. So we can actually, because we version our data files and our configuration files, we can actually go back in time, check out a release tag of our deployment automation, and run it, and it will install that released version of the product with that data, and then we can run a different upgrade task that's also part of the deployment automation that will then upgrade it, and if it fails, we know we have a problem. So yeah, we treat our data files as part of the product, except we don't ship them to customer. So dependency resolution was a major benefit to us, and that's one of the reasons why we were able to get it up and running so quick. But another part is just the built-in functions that are on the Gradle project object make automation of this kind so easy. I mean, we can download the zips through dependency resolution and then use the built-in unzip capability and filter for exactly the files we need and replace tokens if we need to tokenize it for a specific configuration and all that. So that was a big gain. And then just the fact that it's now running directly in a task graph. So we don't need to tell people, okay, run this installer and then run this configure and then run this data load. They just know, hey, I want this data loaded product. I run the data loader and everything else just runs for me. So that wasn't even something we really thought about up front. It just is the way it worked out after we started the automation. So at this point, we've got how to automate the deployments solved. So now we got to figure out where are we going to deploy them and what's the best way to do it. Seeing that we don't control the production deployment for an on-prem product, there's only two things we have to worry about: developer deployments for testing and user acceptance test deployments before we do a release. I mean, they run nightly, but. So we'll start with developer deployments. And for a UI developer or people who are working high on the stack, close to the UI, they just check out the deployment automation of their laptop and run it, and they've got an environment ready to go. For those of us that work down at lower levels, all of the interesting test cases are when you're testing in a multi-host clustered environment, and what happens when the network goes down but the node doesn't, or what happens when the node goes down and comes back up. So we have to be able to test a multi-host deployment, and that's not the easiest thing to do in general. What we came up with is just a combination of a couple tools. You're probably familiar with most of them. The first one's VirtualBox. If you're not familiar with it, this is a VM host that'll run on any x86 hardware. Sun bought it and then Oracle bought Sun, so it's currently an Oracle product. It actually has really permissive licensing where, now I'm not a lawyer, so double check this before you start using it. If you're using it on your laptop and only you're connecting to it, it's free. If you're trying to set up a server that other people are going to connect to, you have to pay for it. So developer testing, it's perfect. We can spin up 2 VMs in this VM host directly on your laptop, and the only downside is those of us working on this have to have really big, heavy laptops that hurt our shoulders when we carry them to conferences. So, but we need to be able to create the VMs quickly and tear them down and set them back up, so we're going to use HashiCorp's Vagrant to automate the setup and tear down of the servers. For those of you who aren't familiar with Vagrant, it's a tool specifically designed to speed up development environment configuration. Here's an example script. I've removed anything related to networking because the way you set up your box to be on your network and connect to your corporate DNS is not something I can share because everyone's going to be different. It's also honestly the hardest part of getting a multi-host environment working on your laptop. But I can't help with that because everyone's networks is different. So the first 2 lines inside the block are setting up the VM box. And this is basically a pre-built VM template that's going to be deployed. The next line down is setting up a mount point. And the mount point, by default, it has a different mount point, but we needed to move it to somewhere else. The mount point is setting up a local directory on your laptop that will also be mounted in each of the VMs. And this is how you transfer files from your laptop's main OS and the VM. Then we have a little block here where we're setting up some stuff that's specific to the VM. In this case, I'm setting the memory so it doesn't cause my laptop to completely crater. And then the most important part is this block here, where we have a provisioning using a shell and a path to the shell script. Now, Vagrant supports provisioning using Puppet and Chef and all the other ones, but the easiest is we control the operating system. We're just going to give it a shell script. And all this shell script's doing is calling Gradle W on our deployment automation, because we've checked out our deployment automation into that directory here that's shared between the main laptop and the VM. So we can now set up, on my laptop, I can handle up to 3 nodes. It literally adds, once the Vagrant's installed and the script's in the right place, it's one command, and then wait a while for the VMs to start up, and it's great. The problem is sometimes it's waiting a long while because the default template that Vagrant provides, for us, it's the wrong operating system. We don't support Ubuntu. And it's missing things like the Oracle JDK and some other third-party libraries we need installed before our product can be installed. So that's where Packer comes in. Packer is another tool from HashiCorp that you write a big long script. I won't be showing you it here because there's no way I could make it legible on a slide. And it takes a installer ISO of whatever operating system you want, installs it into a brand new created VM, and then you can have a script there that installs things like Oracle JDK and other things you need, and then it bundles up and creates a box that you can upload to your repository for use by Vagrant. We were using Vagrant long before we started using Packer. When we started building our own boxes, it reduced about 30 minutes from our startup time when we were creating a new clean template, or a new clean node on our box. So here's what the deployment ends up looking like for those people who think pictures make it easier to remember. We've got Packer in the upper corner here, and it's pulling the ISO out of our product repository. It's creating a new template and pushing the new template, the new VM template, back into the repository. And then we've got our version control system. The developer clones our deployment automation, which includes the Vagrant script, and whatever code they're working on. They run Vagrant. It starts up 2 nodes inside their VirtualBox, and then it runs the deployment scripts inside each of the nodes, and now they've got a multi-host environment ready for testing. They can do a code change, copy it to that shared directory, bounce services, and they're in production. It's the fastest cycle time we've ever managed to come up with. We've tested trying to use real virtual machines in the cloud, and the cycle time just is too long once you get the transfer time in there. So that's it for our developer deployments. So at this point, all we got left is user acceptance test deployments. And they're actually not that interesting compared to all the other stuff because they're so simple. We just have a Jenkins server that runs a whole bunch of builds every day. The only thing that's really different is normally Jenkins deploys, you've got a build and you've got a pool of agents and the build says, run me somewhere, tell me when I'm done. In our case, our agents are very specific. Our agents equal a customer environment. So rather than having a pool of similar agents, each agent is we support 4 operating systems, 6 databases, and 3 OLAP engines. And each agent is configured to mimic an actual customer environment. So we know we've got 5 customers that use operating system X, database Y, and OLAP engine Z. So we're going to set up 2 or 3 agents with that configuration. And then our builds, some of our builds will say, I want this test run on every single agent. And other ones say this test should be run on agent X and Y, and the agents really matter. They're not an undifferentiated pool. They are specific recreations of our customer environments. So we're talking about UAT, but we haven't mentioned what we're doing for acceptance testing. Question? So our product doesn't currently support Docker. We will at some point. Part of the problem is a lot of our customer deployments are so large that having a VM layer doesn't make sense. So I mean, one customer I've worked with has a 4-node deployment, and each node has half a terabyte of RAM, and they actually they run out of memory occasionally. So we're not mimicking the size of their VM, their host, by the way. We're just mimicking the operating system. But because our customers aren't deploying in Docker, we're not going to test using Docker, because then it wouldn't be a valid acceptance test. So haven't mentioned how we're doing acceptance testing. It's not that exciting. We're using Cucumber. Specifically, we're using the Cucumber JVM flavor, because almost all of our products run on the JVM anyway, so there's no additional work for us to set it up. We wrote our own custom plugin to run Cucumber JVM. Now, there's actually a Cucumber JVM plugin out there that someone's contributed. I don't know how robust it is, but it's a really good Gradle plugin. We didn't use it intentionally. We didn't write a configurable plugin. We literally wrote a very opinionated plugin that says, hey, at our company, we think that we should run Cucumber this way, and the only thing the caller can configure or needs to configure is they can add some system properties, and they tell you the path of where the feature files are stored for the tests. And that's incredibly simple to do. Our task actually just extends the Gradle Java exec task, and we basically we wrapped the task action, and we just reset all the values to what we want them to be before we call super.taskAction. And I would highly recommend, if you're trying to simplify your builds for a distributed number of teams, writing in-house opinionated plugins is a quick way to make your builds run easier to maintain. And because we did it with a Gradle task, now it becomes even simpler. It's part of our deployment release. It's part of our deployment automation. So you don't say, hey, I'm going to deploy this environment, then I'm going to run a test. The tests are part of the task graph. So you just say, I'm going to run this test, and it knows exactly how to set up the environment it needs to run successfully. So our deployments for UAT, same thing, pretty simple. The Jenkins server checks out the release automation, including the acceptance tests from VCS routes. It pulls the product and all of the data from the product repository and runs them on different agents. And here I've got one Windows and one Linux agent. In reality, we have dozens. So that's pretty much it for how we automated deployments. But it's not all of the automation we had to do. So for people who work on a product where you own the server it's deployed on, a release is really simple. You build the component, you upload it to the server, you bounce services, you're done. If you're doing immutable infrastructure, maybe you build the component, you create a new VM template, you do some kind of red-green testing, switch over, and you're done. And if you own the server, you're generally only supporting one or two versions. For on-prem products, we don't control the upgrade. We don't control what version they're on. Every single customer could potentially be on a different version of the product, and we have to be able to maintain all of them. And releases for an on-prem product can be simple, but part of it is you have to do a simultaneous release of every component. And if you have a simple product, that's simple. If you have a complex product, it's a complex release. So our release infrastructure looks pretty simple. We've got our version control system. We've got a continuous integration server. We're using TeamCity server at the moment for our continuous integration. We have component builds, which pull third-party dependencies and other components out of our component repository, runs the build, quality checks the whole 9 yards, and pushes the new component in. And then we have a product build that all it does is it pulls all the pre-built components into one place, bundles them up, creates the installer package, and then pushes the installer into the product repository. So at this point, it still seems simple. But this is a simplified version of our component graph for our product. Simplified because I actually had to delete about 1/3 of the components to get it to fit on a slide, even by shrinking the text to the point where I guarantee most of you can't read it. It looks like a mess, but it's not. It's actually clean separation of concerns. And it's like that for a reason. And it actually evolves over time as the product evolves. So we don't have a simple release. We don't have a simple product. It actually gets really complicated. Integration, so how we handle integration testing between all the components is out of the scope of this talk. It's, for some of the components, it's just we do user acceptance testing end-to-end with the product deployed. We have no manual integration tests between components, no. It's all the ones we have are automated. We do have a small subset of manual test cases that we run on the product. No matter how much automation you have, you always want a human looking at a product before you ship it to customers. So this is a simplified version of the product. In reality, we've got approximately 38 repos, 101 separate builds, and we have 100+ individual code contributors to one product. And a manual release takes approximately 4 man-weeks of effort. We release monthly. So if we do this manually, we literally are having 1 man-year of effort into doing releases every year. So something had to give. We needed to fix this, so we had to automate it. It wasn't really an option. So for an on-prem product, the release process is complex. You have to create a release branch so that if the customer who's on an old version finds a bug, you can fix it. You have to update the versions on master after creating the branch so that people can continue working on master for the next release. You have to create a new build for the branch, which is actually where the majority of those 4 man weeks comes from. Creating 101 builds manually takes a lot of time. Then you have to update the dependencies to remove any snapshots, run the release build, tag the repository, and then go back to number 1 for the next repo. No one liked doing this. It was incredibly painful. So of course we did a custom Gradle plugin, or I wouldn't be talking about this. And it's too complex to get into much of the code, but I'm going to go over the DSL we came up with. When you apply the plugin, it's adding 2 extensions. And the first extension is the build environment, and the second one is the complete definition of the product. And the build environment is literally telling the plugin where all the servers are it needs to know about to run a build. So it's got the URL to our TeamCity continuous integration server. We developed the plugin on a previous version of TeamCity, so we have to tell it to use backwards compatible REST API. We're planning on upgrading that this month, but anyway. We've got to tell it where our version control system is. We're currently using Stash, Git repository from Atlassian. Yeah. And where our Maven repository, which is JFrog Artifactory, I think. So this is pretty simple, just a couple of properties. The product obviously is pretty complex. So at the top level, we have all of the variables that are consistent across every component. And part of the effort of releasing is we had to standardize all of the components. So at this point, we've got one product name, obviously, but we made every single component use the exact same Maven group ID. So we can define it here. Every single component goes into the same product install, so we've required them to all use the same Java home to build. And then we have a section to configure the version control routes and the builds themselves. So in the version control routes, we actually have a nested layer where it says Stash. And this second layer is specifically because in the past 10 years, we've had 3 different version control systems. We keep migrating to something newer, better, more fully featured. So the assumption is at some point we're going to do it again. And when that happens, we can just add another layer for the other one into this. So in the version control routes, or VCS routes, we specify everything it needs to find every single repo in the product, and that includes all of the repos for build automation and QA, the data for loading the deployments and stuff like that. The builds was more complex. Up until now, everything had been simple beans where you're just setting values. At this point, these are actually method calls that are taking a configuration closure that's doing a rehydrate on the build object that's created. If that's gibberish, that's the way most of the configuration objects in Gradle work. We might have possibly looked at Gradle source code to figure out how they got it to do it, not being Groovy experts. So that's where the configuration is actually, the contents of the closure is applied to the build object that's being created. We currently support 3 versions, Gradle Ant and Ant Suite. Ant Suite is just a legacy of our old Ant system where it breaks the build up into multiple builds for better parallelization. So Ant doesn't have any. So this is what I would call a well-behaved Gradle build. This is literally the minimum configuration needed to do a build in our system. So it's got to have a name because we need a way to uniquely identify it because we need to be able to both create and update builds. So if someone wants to change a build, they actually have to change it in source control and then run the automation task to update the TeamCity. So we're matching on name. It has the VCS route. We have an optional thing for schedule nightly build where it's true. Generally, we only have the root of the tree that has no dependencies on other components, schedule nightly build, and that should trigger builds up the tree after those run. And then there's the trigger dependencies, which is, hey, if this other build runs, I want this one to run because I depend on it. So we get a true continuous integration. If you push low on the stack, it will cause builds to cascade all the way up to the top of the tree. Max build time is, TeamCity's nice enough to let you configure it to kill builds if they're misbehaving and not ending. and then produced artifacts. And produced artifacts seems like a strange thing to put, but it's absolutely vital for part of release automation. Part of release automation is you need to be able to make it idempotent so you can run it repeatedly. You've got 101 builds that you're running 12 times a year for release automation. At some point, one's going to fail. You're going to have a database outage, a network blip. Something's going to happen, a build's going to fail. So we need to be able to restart release automation with as minimal effort as possible. So what it does is when you run a release, or we can also force a snapshot build after changing versions, it goes to each build. I need to step back a sec. The trigger dependencies let us build the graph of what our product is. So we can build the graph from the trigger dependencies and then start at the bottom and work up. And the produced artifacts let us say, okay, I'm on this build. Let me check Artifactory to see if its artifact already exists. If the artifact already exists, don't run the build, just go to the next build. Keep going up the tree. And this lets us, when there's a failed build, just restart it with no manual effort. The only thing it can't handle is if you've got two artifacts like here, and one publishes and the other doesn't, it panics and dies. And you're going to have to go fix your Artifactory. Because I don't even know how you'd automate fixing that. So this is what I'd call a well-defined build. And to get this short of a build definition, we had to standardize our builds as much as we could. But even then, there were some builds that we couldn't standardize. So there are things in the DSL that you can additionally configure. So some of our components run integration tests as part of their CI build, so they need a database. So in this case, they're setting an agent requirement that says my build can only run on an agent that has both Oracle and SQL Server installed and available. And we actually have like 4 or 5 different additional capabilities like this built into the automation to handle the not well-behaved builds. But most of them are really specific to Team City, so I'm not going to get into it. So release automation, basically it has to be able to configure the build, run the build, monitor the running builds in parallel for speed, and restarting after build failure. Our first version of the plugin didn't handle parallel builds where there's 2 components with no dependency. They just still run in sequence. When we added the parallelism to our particular product, it actually shaved about 8 hours off the release time. So that was definitely worth our effort. And then in the version control system, we just had to automate creating a branch. Oh, I missed. Also, we have to be able to add a tag. And then we have to be able to actually change the code in the version control system in an automated way, because we have to literally go into Gradle and change the version of all of our dependencies to not include snapshot. So for the Gradle builds, we just added all of our product-related component dependencies, use a Gradle property for the version. So the release automation actually goes through and modifies every Gradle property in our product to change the dependency variable to no longer include snapshot for the release build. And after the release, it has to update the version. So our release automation was a complete success. We're very happy we invested the time. This was not quick. So our deployment automation ended up being relatively quick. This took several months. We went from 4-man weeks of manual effort to about 2 hours per release. And depending on, our Team City is shared across many products. If only our product is building at the time, it's about 12 hours. If there's multiple products, it obviously gets slower. Cool. So the last batch of stuff we've done is license compliance. This is actually really simple. I almost left it off, but it's a really good idea. So as everyone knows, if you put GPL code in a commercial product, you're in bad shape. So we wanted to make sure with 100 plus code contributors, the chance of a bad dependency getting added in is pretty high. So we wanted to make sure that we could guarantee we never shipped a product with a bad dependency. There's commercial offerings that cost a lot of money. We looked into some of them and decided it wasn't worth it. The problem is violating the terms costs even more. So we really didn't want to do that. Of course, we already had an in-house repository. So I mean, the first line of defense is just if it's something you shouldn't put in the product, don't put it in the repository. The problem is we share this repository for both product builds and the quality checks. And we use plenty of stuff for quality and testing and deployment that has a license that's not compatible to ship with the product. So we have things in our repository that have invalid licenses to go in the product. And at one point, someone just went, well, this is simple. Let's just upload the license directly to our repository with a classifier of license. And then if it's got a license that says don't go in the product, you still upload the license text, but you change the classifier to don't redistribute this. And then we've got a Gradle task that does a license check. For on-prem, we actually have to ship all of our open source licenses with the product for license compliance. So we give it a license directory where it's going to download all these license files to. We point it to the repository. And then we give it the configuration that contains all the dependencies that we want to check. And the implementation is pretty much on this slide. That's all there is to it. You just get a list of strings, initialize it to empty. You loop through all of your dependencies, and you do a simple download. So here we're building the URL. Depending on what your repository looks like, that'll change. But it's pretty simple. You do a download, and in Groovy, there's a one-line command to do a download, but it ends up being longer than the slides, so I took it out. And if you get a file not found exception, you say, hey, this particular dependency was not licensed to be redistributed. And you just add that artifact ID to the missing licenses, and when you're all done with the check, make sure that the missing license list is still empty. And that's it. So some of the commercial offerings wanted about tens of thousands of dollars to do the same thing we did with 20 lines of code. No, we are standardizing. We upload the license for the jar or the dependency at the exact same coordinate with a classifier of license, or with a classifier license no dist if it shouldn't be used. So, I mean, we control that. The only really difficult part remaining is how we determine what the license is. But that automation was written in Golang, so it's not really applicable to this conference. So our full infrastructure for both release automation and all of our deployments fits on one slide. We've only got 4 moving parts other than Gradle. We've got our CI server, our UAT server, and 2 repositories. And we've got complete deployment. We got complete automation of everything except the production deployment. And that's all I've got. Any questions? Oh, come on, I'm 30 seconds under time. Well, that's it then.